Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at inequalities. So these are very similar to equations, but instead of having this equal sign, we don't have that. We have one of the inequalities. So inequalities look like this. You will have seen them before. So people often get mixed up which one is which. So these two pointing to the right, they're talking greater than, and the two pointing to the left are less than. So the reason they point the way they do, remember our number line, we go from left to right, like it starts at 0 and then it goes to 1, 2. As you're going to the right, numbers are becoming greater. So points to the right is greater than. Another way to remember it is the crocodile eats the larger number. So if I have 4 and 3 like this, the crocodile eats the larger number. Think of this as a crocodile's mouth. So this is saying 4 is greater than 3. Pointing to the right means is greater than. So what am I going on about? So instead of having something like x plus 1 is equal to 4, we know how to solve that. It's easy. X equals 3. But instead of having that, what we do is we replace the equal sign, and instead of an equal sign, we might have a greater than sign. So we're going to solve inequalities, things like this. X plus 1 is greater than 4. Now, your intuition probably tells you that unlike equations, there's not just one solution. There are, in fact, infinitely many solutions. There are infinitely many numbers you could substitute for x to make this statement true. You could substitute x is 4, because 4 plus 1 is greater than 4. That's a true statement. You could substitute x equals 5, because 5 plus 1 is greater than 4. You could substitute x equals 100, because 100 plus 1 is certainly greater than 4. You couldn't substitute something like x equals 2, because 2 plus 1 is not greater than 4. But there are still infinitely many solutions. But we want to be able to write all of these solutions. We don't want to spend all day, though, writing out 1,000 possible solutions. So instead, this is what we do. We're going to solve this just like a normal equation. So if we had something like x plus 1 equals 4, we would just subtract 1 from both sides. So we're not going to do anything different here. Let's subtract 1 from both sides. So 1 and 1 cancel out. I get x. 4 minus 1 is 3. And I just write the symbol x is greater than 3. This is how I can write all of these solutions conveniently. This basically says I can choose any number for x that is greater than 3. I can choose x is 4, 5, 6, 100, whatever. So x is greater than 3 is the solution to this inequality. That means, again, if I substitute any number for x that's greater than 3, this will be a true statement. So I can display this on my number line up here. So this is how you draw an inequality. So start off with a circle on the value. So x is greater than 3. So I'm going to put a circle here. Now, I want to include all the numbers that are greater than 3. Greater than means points to the right. So all you do is draw a line that points to the right. This displays all of the solutions, any number that's greater than 3. The arrow means it goes on forever. So it goes past 5. It goes to 6, 7, 100, and keeps going forever and ever. So this is how you graph inequalities on a number line. So just a point when you're graphing inequalities, if you leave an open circle, that means it does not include that value. And if you shade in the circle, it does include. So we would use an open circle for greater than or less than, which doesn't include the value. We would use a closed circle for greater than or equal to or less than or equal to. All right, that's a bit of an introduction. Let's look at a few more examples of solving inequalities. So let's solve these two inequalities. We will do it using the exact same steps that we do for equations. So looking at this one here, this was an equation. We just start by subtracting 4 from both sides. So then we get 5x is greater than 9 minus 4 is 5. The way we undo timesing by 5 is by dividing each side by 5. So we get x is greater than 1. So if I want to graph this on a number line, which you will often be asked to do, let's just put a few numbers either side of the number 1. So x is greater than 1, so start with the circle here. We want all the numbers greater than 1, so we're going to the right. Now I leave this as an open circle because it doesn't include 1. If I substitute x equals 1 into this, I get 5 times 1 plus 4 is greater than 9. In other words, 9 is greater than 9. But hang on, 9 is not greater than 9. So if I substitute x equals 1, I do not get a true statement. X equals 1 is not a solution to this inequality. That's why I'm not including 1. Let's look at this one here. So you know how to solve equations with fractions. The first thing we're going to do here is multiply each side by 5. So once again, don't get fooled. Don't times the top of this fraction by 5. We're just timesing the left-hand side by 5 and the right-hand side by 5. Times 5, divide 5, cancel out. We're left with x minus 3 on the left-hand side, 7 times 5 on the right-hand side. So now I'm just going to add 3 to both sides. I'm going to leave the inequality sign as it is. X is less than or equal to 38. So if I want to draw this on a number line, put 38 in the middle, couple of numbers either side. So this time I'm going to start at 38, but I'm going to go to the left because I want the numbers less than 38. Now this time I am including 38 in my answer because this is less than or equal to. So this time I have to shade in the circle. You see, this time if I substitute x equals 38, I get a true statement. If I substitute x equals 38 up here, I get 38 minus 3 over 5 is less than or equal to 7. 38 minus 3 is 35. So I'm really saying here 35 over 5 is less than or equal to 7. This is actually a true statement because 7 is less than or equal to 7. 7 is equal to 7. That's why I included it here. So when you've solved inequalities like these ones, you should check your answer. All you have to do is substitute a value over here and make sure it's not included. If I substitute 39 here, I get 39 minus 3 over 5. I get 7.2 is less than or equal to 7. That is a false statement, so I know 39 is not included. All right, I've got to make a bit of a confession. I did tell you a bit of a lie. I said we solve these inequalities just like we solve equations. Well, that is true for the most part, but there's one exception. There's one time that we do something different when solving inequalities than when solving equations, and I'll go through that on the next slide. So the only thing that we do differently when solving inequalities than solving equations is that if we multiply or divide both sides of an inequality by a negative number, we reverse the inequality sign. So let's look at an example where I can show you what I mean. So let's say we have 18 minus 2x is less than 10. So we are going to solve this very similarly to solve an equation. So we're still going to subtract 18 from both sides. This is a positive 18. To get rid of it on the left-hand side, I need to subtract 18. But what I do to one side, I must do to the other. So now the 18 and minus 18 cancel out. I'm left with minus 2x is less than minus 8. So to get x by itself, I'm not dividing each side by 2. I actually need to divide each side by negative 2. So this is what I mean dividing each side by a negative. So dividing minus 2x by minus 2, I just get x. Minus 8 divide negative 2 is positive 4. But because I've divided each side by a negative, I need to reverse the inequality. So it was a less than, it now becomes a greater than. So let's look now at another such example. So we're going to start looking at this just like a normal equation. So we're going to multiply each side by 5. So once again, don't be fooled. You don't multiply this top part by 5. You're just multiplying the whole fraction by 5, multiplying the other side by 5. So now what I would need to do is subtract 4 from both sides, similar to over here. The way I'm going to get rid of 4 on this side is subtract it. So I get minus 3x is greater than or equal to minus 9. Now I didn't switch the inequality here. Here I'm subtracting a number. You only switch the inequality when you're multiplying or dividing by a negative. The next step involves just that. Now I'm going to divide each side by negative 3. So I get x on one side, minus 9 divided minus 3 is positive 3, but because I divided each side by a negative, I need to reverse the inequality. So from being a greater than or equal to, now it's a less than or equal to. And this is the only thing you do differently when solving inequalities than solving normal equations. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.